Hello, students, and welcome to our lesson where we are still talking about translating expressions, that language of algebra, turning it into the specific expressions, the numeric and variable representations of algebra. So we're going to start with our do now prompt. This lesson is the same for those who have class on February 8th, Monday, and those who have it on February 9th, which is Tuesday. The only thing different is our do now prompt. For February 8th, we're going to talk about family contracts. And for February 9th, we will talk about being respected and free from harassment. So we just have two different do now questions. After we do our do now, our objective in both cases will be to continue to translate expressions. And our essential question, remember, what is a turnaround phrase? We started talking about this. And why is it important to be able to translate words to algebra? Our assignment will be to answer our do now in class notebook. It's all in your Q3 folder. We're going to watch the video and complete one assigned page today. And we'll answer the exit ticket in our folder. The most important thing, make sure you show me your work. So for our exit ticket, we will write two ways to represent the following expression in words. So remember, show me your work. If you're having trouble with your camera, you could take a picture with your phone and just send it to my email. If you don't get done the lesson, show me what you've done. You always show me your work. If you're not finished, you'll be able to finish it for homework. So really important, make sure you have your camera on, that you respond when we call your name at the beginning, middle, and end of the period, that you show me your work. If you have any questions, there's my email. So let's move on. We have two do nows I'm going to talk about. The first one is for the Monday group. That would be third period. A family contract is an agreement with family members on how we want to treat each other, how we want to share tight quarters, and how to resolve agreements. What rules should a family contract contain regarding school equipment and supplies? And I would think you might want to have a rule that says, you know, even though maybe Mrs. Gold gave you some markers and crayons and notebooks, that they're yours. Younger brothers or sisters can't use those. Maybe you have a rule that when you're doing schoolwork, when you're doing distance learning, that you have to have a quiet room to do it in, and nobody can come in while you have maybe a little sign on the door that says, do not disturb, I'm distance learning. Think about what rules you could make that would help you be a better distance learner and help you take care of all the school equipment and supplies you have. Maybe you have a rule that your Chromebook is only for schoolwork, not for your brothers and sisters to watch movies. So think about that. Those that have math on Tuesday will be thinking about this. It is everyone's right to be respected for who they are and to be free from harassment. It is everyone's responsibility to respect and not harass others. If disrespect and harassment are wrong, where do people learn these behaviors? Where do people learn how to do things that are unkind, unwelcome, or hurt others' feelings? Where does that come from? How did they get that? Think about that. Okay, we will, in both cases, we will go back to the exit ticket. But let's move on to our lesson. So we started translating words into algebra. And now we're going to have a little bit of practice with it. We're going to practice going from words to algebra and then going from the algebra to back to the language. So number one says the product of a number and -8. I'm going to use, I guess I'll change the variables up a little bit just to give us practice with something other than X. Sometimes I'll use X, sometimes I won't. But whenever we see the expression, a number, we're talking about a variable. Okay, and the variable could be X or A or B or C or any letter that we choose. Sometimes when we do word problems, we might choose a variable that has something to do with the problem. So if we're selling tickets, we might want to use T, or if we're measuring sugar, to make cookies, maybe we'll use the variable S or C for cups of sugar. So that can change, but the rules are the same no matter which variable you use. So when we say the product of a number and -8, the product is when we multiply. And when we multiply a number times a variable in algebra, we typically put the number first. So this case, we would have -8, and we'll use n. Now, a number increased by 35 is addition. So if we make that number y, it would be y plus 35. And we'll learn in the next couple of lessons that that is two terms. Terms are separated by addition and subtraction. 2/5 of a number, 2/5 is a fraction of, indicates generally multiplication, and a number is our variable. So we can have 2/5 G, or any letter you use. The quotient of a number and 4, quotient means we are dividing. Our number is our variable. We can use n. And 4. Now this and is not addition. And we know that because it says the quotient of a number and 4. So if we use n, then it's just divided by 4, the quotient of a number and 4. Number 5, 18 less than a number. If we use C, so we have, now here's the thing, this is a turnaround phrase. This is not 18 minus n, okay? No, that's wrong. This is 18 less than a number. So the n goes first, minus 18. Okay, this is a turnaround phrase. So 18 goes to the right of the number. Number 6, 24 hours per day. We are multiplying 24 times any variable. Since it says per day, we'll use D. And number 7, it says the total for parking and an admission ticket. So this is adding, this is addition. And we'll use P for parking and A for admission. So P plus A. Number 8, $3 subtracted from the cost of the book. Subtracted from is subtraction, but that is also another turnaround phrase. So we've got the cost of the book, and then from that we are subtracting 3. And number 9, it says the sum of twice a number and 15. So we're adding and we're multiplying. So the sum is the addition. Twice a number is 2 times a number, we'll call it n. And then what we're adding to 2n is the 15. So the sum would be 2n plus 15. Number 10, the difference, that means we're subtracting, of a number squared, so we'll have an exponent of 2, and 6. We are not adding here, okay? We're subtracting. It says the difference. So we've got a number squared and 6, and we're subtracting 6 from the number squared. So if the number is n, it would be n squared minus 6. So I hope you could try the next few on your own and see how you did, then check them with me. So it'd be good to pause the video, try some of these on your own, and then come back. Okay, so number 11 says half of a number decreased by 27. So we have 1/2 of is multiplication. So if we use n. We're also subtracting because it says decreased by 27. So that would be 1/2 n minus 27. Number 12, 10 more than a number divided by -8. So we've got two expressions here. We've got 10 more. So we're adding 10. 10 more than what? A number divided by -8. So here we're going to have a number divided by -8 plus 10. Now remember, addition is commutative. We could say 10 plus a number divided by -8, and that would be okay. Does not work for subtraction, does not work for division, but for addition and multiplication, those are commutative. Number 13, 9 less, so we're subtracting less than, is a turnaround phrase. The square root of a number. So the square root of a number has to go first. Let's use s. So we have a square root of s, and then we've got 9 less. So the square root of s minus 9. In number 14, -4 times a number plus 29. So we're multiplying. Okay, why don't we use, let's use the letter y. So -4 times y, and then to which we add 29. So -4y plus 29. Now remember, addition is commutative, so we could also say 29 plus a -4y. We're adding the opposite. And number 25, or number 15, excuse me, has a 25 in it. 25 is decreased by the product of a number and 3. We've got 25, and then we're subtracting, and product is multiplication of a number and 3. So this is not addition. It's a multiplication of a number and 3. And 25 is decreased by that. So if 25 is decreased by 25 minus 3 times the number. And number 16, 7 points more than twice the number of points scored by the other team. So let's use P for points. So 7 points more, we're adding, and then twice the number, we're multiplying by 2. So we've got 2 times the number of points plus 7. Now we're going to go in the other way. We're going to give 2 different ways to write each expression. So number 17, we have x divided by -7. So when we divide, we have a quotient. So we can say the quotient of a number and -7 . Or we could simply say a number divided by -7, which is what I said when I first introduced it. Now, number 18, we've got -4 times n, or times a number. So we can write that first, -4 times a number. We can also say when we multiply, the answer is called the product. So we could say the product of -4 and a number. Remember, we're not adding because we use the word and here, because we used the word product here. So number 19, we've got, I want to talk about this k over 3. We can represent this k over 3 as 1/3 k. That is the same thing as k over 3 because what we have here is an invisible 1. So we can say 1/3 of a number increased by 16 We could also say when we add, we get the sum. So we can say the sum of a number divided by 3 and 16. So the sum of a number divided by 3, that's k over 3, and 16, which is what we are adding to it. And in the last one, we've got 2a minus 18. We can call that the difference, because we're subtracting, the difference of 2 times a number and 18. You don't want to say plus because we're not adding, we're subtracting. The difference of 2 times a number and 18. Or we can say 18 less than twice a number. 2 times is the same as twice. So it'd be like a turnaround phrase. 18 less than twice a number. So let's go ahead and let's look at the exit ticket that I have planned for you. It says write 2 ways to represent the following expression in words. Well, we could say 4 less than twice a number because we're subtracting. I'm going to change my color to get something a little darker here. And we could also say the difference of 2 times a number and 4. And there we have it. I hope you're enjoying my beautiful Valentine's decorations, digital Valentine's decorations. I hope you talked about the family contract um, or the other do now if you're in period 6 and 7. I know that you're working very hard. Please remember to show me your work. And I appreciate how hard you're working, how hard you are working to not just in your math, but dealing with this technology. And I know there's sometimes issues with it and the lagging, but you guys have shown such determination. You get kicked off a meeting, you get dialed back in, and you've been writing to me and sending me emails telling me what's going on with your technology and your life. And I really appreciate that. I think that's wonderful. So, you guys are working so hard. Keep doing it, keep practicing, because you know what? As you do, you'll be great.